We will try to understand the properties of chords of circle and different types of circles while solving problems in this video. Let's solve first problem. Draw 3 concentric circles of radii 1.5 cm, 2.5 cm and 3.5 cm with O as center. Before solving this problem, let me tell you what are concentric circles. Circles having the same center but different radii. Let me show you. Consider this as center point O. Now, keeping this as a center, draw a circle of radius 1.5 cm. Now, I will draw another circle. Keeping point O as a center, again I will draw a circle of radius 2.5 cm. These two are concentric circles, as these both circles share same center but different radii. Let me draw one more circle. Keeping the same center point O, I will draw circle of radius 3.5 cm. All these circles are concentric circles and hence we have solved the problem. Let me solve another problem. With O1 and O2 as centers, draw two circles of same radii 3 cm and with the distance between the two centers equal to 5 cm. Problem states distance between centers of two circles is 5 cm. So, mark 2 points O1 and O2 at distance 5 cm. Now, draw circle of radius 3 cm keeping O1 as center and draw another circle of radius 3 cm keeping O2 as center. Let's solve another problem. Draw a line segment AB equal to 8 cm and mark its midpoint as C. With 2 cm as radius, draw 3 circles having A, B and C as centers. With C as a center and 4 cm radius, draw another circle. Identify and name the concentric circles and congruent circles. You already know what are concentric circles. The circles of different radii but sharing the same center point. Congruent circles are the opposite kind. Circles with same radii but different center points. Let me draw a line of length 8 cm. This is line AB. Now mark the midpoint. Name this point as C. Now we have 3 points A, B and C. First draw a circle of radius 2 cm keeping A as center. Now draw another circle of radius 2 cm where point C is the center. Third circle is also similar. The one B as its center and radius of 2 cm. The last circle has radius 4 cm and point C as its center. Let me call these circles C1, C2, C3 and C4. We are supposed to identify concentric circles and congruent circles. C1, C2 and C3 are congruent circles because they have same radii but different centers. All these circles have radii 2 cm. Circles C2 and C4 are concentric circles because these circles share same center C but different radii. C2 has radius 2 cm whereas circle C4 has radius 4 cm. Let me solve another problem. Draw a circle of radius 4 cm and construct a chord of 6 cm length in it. Draw two angles in major segment and two angles in minor segment. Verify that angles in major segment are acute angles and angles in minor segment are obtuse angles. Before solving this problem, let me explain you some properties of segments. Look at these two figures. In both the figures, dark area represents the segment of circle. In first figure, it is minor segment. Minor segment does not include center of the circle. Segment is formed outside of it. The second figure shows major segment. In major segment, the center of the circle either falls on the chord or else included in the segment. There is one more unique property about these segments. In minor segment, angles are always obtuse angles, wherein major segment, angles are always acute angles. Well, that is what we are going to verify in this problem. Consider this as center point O. Draw a circle of radius 4 cm. We will draw a chord of length 6 cm. Mark a point P. Considering this as center, we will draw an arc which intersects the circle at point Q. Measurement while drawing this arc is 6 cm. Connect P and Q. We have chord of length 6 cm. This is minor segment, whereas this portion is major segment. We will draw angle and verify in minor segment angle is obtuse and in major segment angle is acute. Let's deal with minor segment first. Consider this point. Name this point as A. Now connect A and P and A and Q. Now measure the angle PAQ. This angle is above 90 degrees. Hence, this is obtuse angle. You can go ahead and try to measure considering another point in this segment. It is always obtuse angle. Now, we will verify the property with major segment. I will mark this point as B. Connect P, B and Q and B. Measure the angle PBQ. It is below 90 degrees and hence it is acute angle. Result will be same if you choose any other point in this segment. We have verified the properties successfully. Let me solve last problem in this video. Draw a circle with center O and radius 3.5 cm and draw diameter AOB in it. Draw angles in semicircles on either side of the diameter. Measure the angles and verify that they are right angles. This is point O. Considering this as a center, I am drawing circle of radius 3.5 cm. We have diameter AOB. This is semicircle. We are supposed to verify angles within this segment are always right angle. Let me randomly choose a point C. Now connect AC and BC. Measure the angle ACB. This is exactly 90 degrees. Hence, we have successfully verified that in semicircles, angles are always right angle.